Thanks everybody for joining us. Welcome to the Hawaiʻi Groundwater Recharge Tool stakeholder workshop. Let's see. My name is Sean Cleveland. I'm at the University of Hawaii in the Information Technology Services Research Cyber Infrastructure Group. I've been on this project since 2016, and I'll be one of the presenters today. Joining me will be some folks from the US Geological Survey. So Kolya Rotzel and Scott Izuka will also be participating and presenting on some of their work. They've kind of been the vision and the science drivers behind the groundwater recharge tool. So we're excited to have them join us and be able to present a lot of the background and be able to answer a lot of the recharge questions. And the other presenter joining us today will be Jared McLean. He is a research software engineer in our cyber infrastructure group, and he's been the lead developer on the groundwater recharge tool, and he did a lot of this work as part of his master's project, and he's continued it on as he's become a professional here. So with that, for today's workshop, we kind of have three main goals that we kind of want to achieve with our workshop. We hope to explain how this tool came to be, sort of the vision behind it, and then we hope that everyone will be able to understand how can this tool be used, what are the use cases that it was kind of designed to address and that it has been applied to, and then also what does it not do, what can it not be used for. And then we'd like to get input from you folks as the community and the stakeholders that this tool was kind of designed to be used by, to see, what are your interests in, expanding areas that this tool could cover. Could there be things that would make it more beneficial? Any other feedback or questions that surround the tool that we could try and answer in this workshop and document in this workshop. So to the end of achieving those goals, here's sort of the breakdown of how the workshop will be structured today. So we have the short welcome, which we're kind of in the middle of. Then we'll be doing a little bit of introduction, and then Kolya will be doing some background, as well as talking about some of the features of the tool, as well as some of the current applications it's been applied to. Jared will be doing a hands-on tutorial and demo. So this tool is web-based, so if you would like to use it hands-on during the workshop, we encourage that, and you can definitely do that. So, and then the last part will be taken up for, as I said, kind of getting your input and your feedback about potential use cases that you'd like to apply this to, or if you're wondering if they fit future work and expansion that would be useful or beneficial to your groups, and then any other questions or things that you'd like to discuss around the tool. So with that, I'm going to hop into some introduction here. So to start at the top, at the kind of the high level of what originally drove the Hawaiʻi Groundwater Recharge Tool to be developed was this Hawaiʻi EPSCoR program. So EPSCoR is the established program to stimulate competitive research. It's a National Science Foundation program that is aimed at trying to help a number of states get more funding, become more competitive at being able to apply for research grants and funding. It sort of has three main goals here. It's sort of on the left the slide here, you can see that it's aimed at trying to catalyze or accelerate innovation, innovative science and research, and translating those discoveries into actionable outcomes for the community, being able to engage with community stakeholders. That's one of the reasons that we have sort of these workshops, is part of this whole EPSCoR ideas. Capacity building. So if you look at sort of by the numbers here, over the last 21 years that Hawaii has been participating in the EPSCoR program, you can see, 23 faculty hires, 847 participants, so many postdocs and graduate students and undergrads. So trying to build this capacity within the state of Hawaii to be able to do research in some of the different areas that EPSCoR tries to pursue every 5 to 10 years. And then the final one is creating workforce pathways for research and industry. So if you want to find out some more information about the Hawaiʻi EPSCoR, you can go to hawaii.edu/EPSCoR and get some more details about what we've been doing and what the program's all about. I'll give you some more information about the EPSCoR program and some of the current projects that are funded. So as you can see here in the dark blue bar, there's a $20 million EPSCoR Track 1 grant. That's the grant that is funded, that did fund the work here on the Hawaiʻi Groundwater Recharge Tool. So this program is called ʻIke, Securing Hawaii's Water Future. So since June of 2016, this program has been in place with kind of the goal of being able to get more accurate and detailed understandings of Hawaii's aquifers, our groundwater flow and transport processes, aimed at trying to help prepare for more sustainability for some of the freshwater resources that we have here in the state. And our group in the University of Hawaii system, so cyber infrastructure, along with folks at Manoa, Hilo, we've been working collaboratively for the last 5 years with a couple research centers and then some federal, state, and county partnerships. So the USGS being one of those partners. And the work that's been kind of done here, some of the big ones here, the research and infrastructure that has been done and built. So currently, we've had researchers that have collected a lot of hydrological and geophysical data to get better conceptual and actionable understandings and enhancing some of the numerical models around some of the main water aquifers that we have in Hawaii, as well as maybe you've heard in the news recently. This has been read, I think, a lot publication-wise. The surface towed marine electromagnetic system that Eric Adius, he's one of the postdocs on the ʻIke project. They were being able to map some of the groundwater systems that were offshore of Kona. So that's been in the news a lot. And then finally, sort of what the Hawaiʻi Groundwater Recharge Tool is sort of fits in, and what our work has been related to is building advanced cyber infrastructure platforms. So this ʻIke Science Gateway, I'll talk a little bit more about, is essentially kind of trying to capture a data repository along with some visualization and decision support tools to assist the researchers who are part of the project, as well as water managers and some of the community stakeholders. So if you're interested, you can go to ʻike.org to see what some of the data available from the project is, as well as some updates and things about that. And then finally, just part of the ʻIke project, as we were talking about some of the workforce and the community engagement and stakeholder impacts, you can see the number of participants that we've had over the last 5 years, as well as the community engagements, being able to interact with over 8,000 community members since 2016, trying to get better understandings of groundwater across the state. And so thanks everyone here for being a part of that and for participating today. And then, so I'm going to dive here into, as I talk about this cyber infrastructure platform, this ʻIke Science Gateway. The whole idea behind this was to bring the data, the models, the computation, analysis, and visualization sort of all into one place, so that the researchers on the project can work with the community, can work with the water managers on being able to have access to hopefully better models, better data, better tools. And to that end, we're currently at a platform that has a number of different tools in it. So the groundwater recharge tool being one of them, along with a precipitation mapping tool, which will actually morph into what will be called the Hawaii Climate Data Portal. We'll do a pitch for that at the very end, along with some tools that we have for researchers on being able to manage and collaborate on their data, annotate it, publish it, being able to manage and run some of their advanced modeling and computational things and resources that we provide at UH, and then having public data access and discovery areas for the data that's coming out of this project. So this is where the groundwater recharge tool fits into this whole ecosystem of tools and data around groundwater for this ʻIke project. So with that introduction about how the tool kind of got funded and has been worked on in the last 5 years, I'm going to hand it over to Kolya to present on some of the background behind groundwater and the features aimed at in the application, and then also how it's been applied. So Kolya, if you'd like to take over, I'll stop sharing.
Okay. Thanks everybody for coming and for joining this workshop. I'll be very enthusiastic to tell you about the basic features and the background of the groundwater recharge tool. This is similar to the talk I gave at the Pacific Islands International, was a tropical island conference earlier, but for everybody who hasn't seen it, it's very gives a lot of feedback. So we all know that groundwater is one of the key recharge is one of the key components for assessing groundwater, and most of the estimates of groundwater recharge in Hawaii use water budget models. And in the simplest form, a water budget model, a water budget takes the amount of water on an island that the island receives, for example, as precipitation, and subtracts all the water that runs off to the ocean via streams or that is evaporated or transpired by the plants. And the remainder is presumed to be the groundwater recharge. Now that is the key because 90% of our groundwater is actually, our drinking water is groundwater, and therefore it's essential to know for planning purposes what's happening with the recharge. So in detail of the water budget, a little bit more complicated. The soil water balance models have to account for a lot of other processes, all the things that cause precipitation, runoff, and evapotranspiration to vary in space and time. And therefore, all these things will be considered within the calculation of, so it's not only what water comes, what rainfall falls and what water runs off, but all the other processes in between are going to be accounted for. And in the end, you'll end up with the water that's recharging the aquifer. And so these recharge estimates using the water budget models require a lot of input from several types of spatial and tabular data sets, for example, including but not limited to soil properties, land cover, of course, reference evapotranspiration and fog interception, runoff, and precipitation. And as much as possible, these data sets are acquired from previous studies, but assembling the data sets can still take some time. And so our typical workflow in how to generate recharge related products is we'll have a proposal that's going to decide on which land cover is going to be used and which precipitation conditions we're going to study. Then we have to gather the data, run the water budget models, and analyze the results, publish the report, and release the data sets as well. And everybody knows that that's going to take some time. That's not going to happen overnight. And the problem is that typically this projections for land cover or climate change are continuously changing and being updated. And so what is needed is a more flexible way to quickly try things out. For example, what happens if land cover changes here or climate conditions change and they're not thought of how they were at the beginning of the study. So you can basically more experiment around with, oh, I want to see the same land cover for a different climate scenario, or let's say the same climate scenario with a different land cover. But that's of course not possible when you already already defined your conditions, what your study is going to be about. However, we have published a lot of and continue publishing these data sets and these recharge reports. However, this attempt is, this study is about to get a little bit more flexible in terms of having the user define what kind of land cover or rainfall they want to have and get the result immediately. And that's where the Hawaiʻi Groundwater Recharge Tool comes in. So this is going to be the landing page if you go to that link that's been shown up there, where you basically start exploring the different options of getting your own recharge data set. And so this is a pilot website. It's currently limited only to Oahu, but it's also designed to be expandable so that other islands could be added in the future. And on the top, you can see other tabs, workspace, background, and so on. So for example, the background tab will tell you a lot about how the whole recharge tool determines the recharge, what goes into it, how the whole thing works. But we have different climate scenarios, the 1978 to 2007 average rainfall, and the 2010 land cover, that's our baseline. And then you can, from then on, you can venture off and change your land cover or change a different climate scenario, which will be the mid-century RCP 8.5 scenario from the statistical downscaling from Ellis and Tim and others. And so what it does, it basically, it has for every cell on the island, we'll have in our data set, you'll have each land cover calculated already and each climate condition calculated. So you only choose what you want to have, and it basically queries the database and gets back the recharge result immediately. So now we're going to move over to the workspace that presents the baseline condition of land cover and the climate condition. So you can see it there. And there you have several, and I think Jared's going to talk to you in depth of how to maneuver within this. So I'm just going to show you a few screenshots. For example, as I said, you have everything is stored in the database, and that is on the 75 by 75 meter grid. So, and you can choose between two different climate conditions, 78 2007 average rainfall and the statistical downscale rainfall for 2041 to 2070. And you also have 29 different land covers to choose from. For example, native forest, alien forest, grasslands, pineapple, corn, diversified agriculture, and so on. And of course, all the developed golf courses categories that you could choose from. Now, it didn't fit here on the screen, but if you scroll further down, you can see all of them. And so how can I change my land cover now? Well, the first thing is you could import a user-defined raster that fits exactly over the raster that we have in here, where we just basically change the IDs for each cell. Jared's going to show you that. And you could also draw a polygon, for example, like this one, and you can change all the land cover within that polygon to be a new land cover. Say that one is alien forest now. You can also be a little bit more sophisticated and create an advanced mapping by changing within your polygon. You change everything that was native forest to alien forest, and change everything from medium density development to macadamia, and everything else stays the same. So that could be a little bit more advanced or more tailored to what other people would have in mind for a specific question that you have. And on the next page, you can see how the recharge will be displayed. You cannot immediately see the difference within your polygon that has resulted now from our advanced mapping change that we did. However, you can already see, you will get an island-wide assessment of how the recharge has changed. In this case, the recharge has changed by about 12 million gallons less from what the baseline condition is, which is about 2%. And if you show the difference map, then you can see what's happening where changes occur. For example, this example, the land cover changes that we put in resulted in a reduction in recharge for the change from native forest to alien forest. You can see that here in the upper slope, so you have less recharge there. However, you see an increase in recharge from the change from medium developed land cover to macadamia. And the net change now is 12 million gallons, and which is about 2%, right, on an island-wide basis. And you can export those information. You can export the whole thing as a shape file, your land cover or your recharge, and or your custom areas. Okay, no, sorry. You can export your custom areas, which is my polygon, as a shape file. And you can export the other land cover and the recharge as either an ASCII file or a COF.json file for your further analysis. And you'll also get a little report that will tell you by the Hawaiʻi State Water Commission management systems. You'll get the different recharge by aquifer. And so you see what it was in the baseline, you see your changes, and you see the difference calculated for each of the aquifers. You also get a little bar graph for the ones that is, of course, not too much, but you can see there's a little change in this aquifer. And I mean, this might be more, if you have more drastic effects, this might be more obvious, but this will help you to identify where these changes occur if you're thinking about aquifer systems. So in summary, the groundwater recharge tool allows users to quickly explore the potential effects of land cover and climate changes on groundwater recharge, and the results can be downloaded for further analysis or application. Now, there, of course, are some limitations. First of all, the grid cell size is only 75 meters, so you won't get more information than that. If you want to see what your own house, that the lot that your house sits on, how the recharge would change, if that would be a different land cover, then that might not really result in much difference on an island-wide scale. However, so this is more aimed at a more island-wide or watershed scale analysis. The differences also in evapotranspiration rates for native and non-native forests are not well known, so you have to be careful with that one too. And of course, the Hawaiʻi Groundwater Recharge Tool does not distinguish between user-defined scenarios that are plausible and those that are unrealistic. So the users are responsible for assessing the plausibility of the scenarios that they test. So if you set your entire island to taro cultivation, you'll end up with an unreasonable number. Next, I want to show you an application, how this has been used. And this is Leah Brema and her team, also through ʻIke funded, assessing the effects of land cover and watershed protection futures on sustainable groundwater management in a heavily utilized aquifer in Hawaii, and that is Pearl Harbor. And now we're seeing here the baseline condition for Pearl Harbor 2010 land cover. What they did then was a stakeholder defined land cover, developed stakeholder defined land cover scenarios. So they have two different urban grow projections, which is the corridor development along the Pearl Harbor line. You can see that in the top row, which is heavily developed high density development around the Pearl Harbor corridor, or the sprawl development. This is a lower row where you have basically going up here, having a lot more medium intensity development. And then there's three different types of forest protection: the high forest protection, which basically leaves the native forest where it is and protects it. And the targeted protection would be only leave a little bit up there, and the no forest protection would be basically wipe out the entire native forest up in the Ko'olaus. So now we're going to look at the two end members of the ones where you have the sprawl development and the no forest protection, and the corridor development and the high forest protection. And also going to assess how recharge changes for the two different climate scenarios that we have for the current and the mid-century rainfall scenario. So for the future rainfall, just look at the future rainfall first. We're not changing the land cover, not only changing the rainfall. You see the difference for the 78-2007 for the entire study area was 201 million gallons per day. For the mid-century climate scenario, it's 170 million gallons per day. And the difference map that will look like this, and you'll see that a change in recharge would be 31 million gallons per day, quite a bit, just based on that climate scenario alone. Now, if you add land cover scenarios, we're comparing the two end members, the corridor development with high forest protection, and the sprawl development with no forest protection. So we're looking at these areas and these areas. And the recharge for these, for the future rainfall scenario now is 168 million gallons per day for the left side and 157 million gallons per day for the right side. So we will do see an increase in recharge in the mountain areas due to the forest protection, and we do see a decrease in recharge in the area where the heavy development from the medium, basically the medium development goes to a heavy development. And so overall, there's 11 million gallons per day. But oh, I'm sorry. So, but overall, the plant development and the forest protection can help to basically increase 7% of recharge for the mid-century rainfall scenario. And the tool goes on further and looks at the analysis from Leah also goes further and looks into sustainable yield and how that affects it. I'm not going to go into that because that goes beyond the tool. I just wanted to show you an example how the tool has been used to run land cover scenarios like this. And so for future development, I just want to show you a few things that are currently available and which could be changed in the future. For example, right now we're only having Oahu. Of course, we're having other islands that are of interest. We only have 2 rainfall scenarios, the current and the mid-century. There's other rainfall scenarios out there that could be implemented. Also, we're always talking about climate scenario, but in fact, we're only changing rainfall. So there would be the possibility to change other climate parameters, temperature, evapotranspiration, and the spatial extent of the fog could be considered. I mentioned the grid cell size is only 75 meters. It could be, this could be smaller, or yeah, it could be even smaller. There's no restriction on that. Of course, then it's a computational question, but that's of interest. That could be done. And so far, the output of the tool is only recharge, so you're not getting any of the other water balance components. However, those could be also included: rainfall, fog, irrigation, evapotranspiration, or runoff. And currently, we are developing a bunch of, in the old process, in the process that I showed you before, together with the Water Commission and others, several water budget scenarios for most of the islands. And of course, if those are available, that might be a starting point to say, oh, maybe we can implement that also into this into the groundwater recharge tool. But that's just an idea for discussion later. I think now we want to head over to Jared and see how the whole thing actually works, so you can actually use it yourself.
Well, yeah, one thing, there's one question here, and I think you might have answered some of it in the chat. So there's a question from Aurora that says, how flexible are the land cover parameterizations? Native and alien encompass a lot of species and structural variability that would affect ET.
Right, they're not. They're not. That's one of the downsides right now. If we have more information on how to define that, and I think there's currently work going on how to do that. At the time when we built this, that was the only thing that was available. If you start splitting it up into Kiave and maybe others, and yeah, you can definitely, if you have more information about it, it could be integrated. But of course, there's a lot of uncertainty about ET and other things for all the different land covers for the invasive.
Okay, thanks. Okay, so yeah, with that, Jared, we'll move on to you. And let's see, Jared is going to do a demo, and then he also has some materials he put together that if you want to follow along, he's got a website here that has some of the stuff he's walking through.
So if you go to the workshop, yeah, you just follow along with the stuff. It has a link to the tool. Then again, can you see my screen? Okay, so this is workspace. First, I was just going to go through some introduction, although Koya covered most of that. There are 9 different land cover types that are represented by the application, as well as 2 rainfall scenarios. And the main purpose of the application is to show potential impacts on groundwater recharge based on changes to land cover. Right now, it covers the island of Oahu. So if you go to application layout, I'll discuss some about just the general overall layout of the application before I get into its features and how it works. So the main component, it has a multi-document layout, so you can actually open multiple instances of the map together if you want to do more than one thing and kind of compare how they differences between potential impacts for the 2. Now we'll just use 1. The main component of it is the map. There's also two different sidebar components, one which has controls that are specific to the visualization. So for this one would be all the controls for changing the land cover types, creating different land cover mappings, and also changing the climate. The right-hand side has more generic controls, so changing the past stable layer, so you can change that so you can kind of see the underlying features on the satellite imagery, changing units between United States customary and metric, importing and exporting data, generating reports, and also doing some manipulations to any custom areas that you might have. If you go into the layer control, top right corner of the map, you can switch to the recharge visualization. So if you go to recharge rate, that will switch visualization style. You can swap this. The default state of this is going to be just displaying the groundwater recharge rates for the island, but you can change that to % change and difference mappings. We haven't changed anything yet, so that's just going to be completely white because there's no change. This also introduces a bottom panel that includes any metrics for groundwater recharge changes. You can see. That's the general layout of the application. So if you go to the next portion, built-in tools, show you how to define custom areas using the built-in leaflet draw tools. So you can change, you don't have to have external data that you import in the application. So you can draw an area. There's 3 different draw tools. There's a polygon draw tool, rectangle draw tool, and a map cell draw tool for more fine-grained detail. So the polygon tool, you can define vertices. So if I have a specific area that I'm interested in, it's around that. The rectangle tool is more simple, drag, and it will create a rectangle. And then the individual cell tool is you can select individual 75 meter by 75 meter map cells if you want some fine detail. So that. So once you actually have the areas that you're interested in selected, there's a couple different ways that you can modify the land cover. The first way is to simply just change everything on the map, or all the areas that you have selected, to a set item. So let's say I want to convert this entire area into a golf course. I can click that, convert that to a golf course. If we go to the recharge rate, that will load in the data, and you can see that in this one, I'll display the difference in groundwater recharge rates based on the modifications to land cover that I made here. You can also, so if I revert these, you can also create an advanced mapping of different types of land cover to other types of land cover. So, sorry, I don't have any of the areas selected currently, so yeah, it won't do anything. This populates only with the line covers that are selected, so that's why it was doing anything before. So let's say I wanted to convert alien forest to native forest, and add more types and convert, let's say, shrublands to cornfields. And then you can have a default which will change any land cover types that don't have a specifically defined rule as well. So if I want to change, I'll just say that and then don't change it, everything else. So leave that as no change. If I submit that, it will create just the mappings that I selected, and then go to the recharge rate and see the differences based on that. If you go to % change, it'll be a little bit clearer the specific areas that were modified. So there's also a difference mapping. And so you can also change the climate scenario. So the default climate scenario is the baseline rainfall, which is based on rainfall data for the island of Oahu from 1978 to 2007. We also by default have RCP 8.5 projection for the years 2041 to 2070. So it's a future rainfall, a potential future rainfall projection. By default, so if I just change this without selecting the update default scenario, it will still keep the baseline rainfall scenario as the point of comparison. So you can see now that it is comparing it to the baseline rainfall for the entire map. So go in the percent change, you can see that there's a change for the entire map. The other thing that you can do is use the baseline. So if we select update default scenario and then go to that rainfall scenario, it will change the point of comparison to this rainfall scenario. So it won't make changes for the entire map, and the changes will only be for the areas that we selected. So you can do either one. So yeah, there's for the groundwater recharge rate visualization, there's a few different options. For the recharge rate specific visualization, there are two different color schemes that are available. So orange, blue, and there's also white and blue color scheme, which is monochromatic. It's a little bit more consistent. And there's also various data modes that are available. So by default, it will show groundwater recharge rates for the entire map. But if there's a specific area that you're interested in, so we only made changes this area. So let's say I'm interested in this specific aquifer, I can switch it to aquifer mode, select this aquifer, and it will only display the changes for that aquifer. You can also do it by custom area. So I can select which areas I'm interested in. So let's say I want to see for those two, it will only display the changes in those areas. And then I can also do it by individual map cell. If I want to do very fine grain analysis, I can select this in a single cell in the map, and it will show just the change for that specific map cell. So for some of the data modes, specifically the full map and aquifer modes, you can also set it to include or exclude the caprock, which is an area around the coast of the island. Actually, it has an overlay, a toggleable overlay that shows where the caprock is. So if you go into the layer control and select that, you can toggle that on and off. So these are the areas of caprock, which are, I believe, higher density rock that contribute less to recharge. So you can turn that off to exclude those areas from the analysis. Then it is, so once you have everything set, you can generate a report, which will give a comprehensive breakdown of all of the changes for all of the aquifer systems, excluding the caprock, any custom areas that were defined. So I have several custom areas. It will show the change recharge for all of those. And then a summary of everything along with graphs. This can also be downloaded as a PDF using this button here. We'll take a second to generate and download this PDF, which just contains all the information, so you can use it outside the application. This also includes some limitations and disclaimers. So maybe provide a couple minutes here so you can play around with the tool. And if you have any questions about the general usage of the tool, then feel free to ask now. And then after that, we'll go into some more advanced features and importing data if you have data sets externally. Where's the caprock delineation come from? So Koya answered that question. So the uploading polygons from the shapefile, I'll get into right after this. So that's probably good. I can. So that's the next portion. If you go to the next part of the workshop, import some areas. That's all the questions. Yeah. Okay, so let me clear the areas that let me just clear off all the changes that I made since stuff. Okay, so for importing custom areas, specifically from shapefiles, if you go to the control panel and hit import, you can select what you would like to import. So for now, we'll do a shapefile. There are 3 different ways that you can import shapefiles, either as a custom area, which is what we're going to do, but you can also import as a reference layer, which is similar to that caprock layer that I displayed, where it's just a toggleable, non-interactive overlay. It doesn't provide any metrics or anything. It's mainly just as like a mask over the map. And then you can also use it as a land cover update. So if there's a meta property in the metadata called LC code, which you can actually change in the advanced options, what you would like that to be called, you can attach specific land cover codes to the shapefile and have that update the land cover from that. So that this will, by default, it will update the land cover from that code if it's available. And you can also have it so that it doesn't actually display the areas on the map, it just updates it as land cover. But we're going to use custom areas, which will be similar to drawing it on the map, just it will import the shapes from the shapefile itself. So if you hit select files, and then there's a shapefile, there's an example shapefile in the workshop if you want to download that. And that's the same file that I'm going to be using. So if you want to follow along, go for and download that and import that into the application. So open. And as you can see, there were, it was a simple shapefile with 4 shapes defined. So if you can toggle shapes on and off so that you can you only have to modify specific areas at a time. So if I can turn that slightly larger one off, I can change, let's say that to diversified agriculture. Then I can change this area into, say, a low intensity developed area. And you can see the difference in recharge rate. So this wouldn't be if I had defined areas in a shapefile that I want to upload and see the effects of modifying them. And then additionally, you can modify the areas in the application and then you could re-export them. So if I realized that there was a feature that I wanted to cover that wasn't quite on the map, that wasn't quite covered by the shapefile that I had, you can go to this edit area and you can add vertices to it. So I could extend this area and make modifications to it, save that. And then you can also name the custom areas. The area names will be the names that are used on the report to specify which areas it's talking about. By default, I believe the names are just custom area 1, custom area 2, etc. But you can change that, and that will also, if you export the shapes from the application, it will add that name to the metadata for the shape in the shape file. So it will add a name property that specifies the name of the area, and if you were to import that into the application later, it would have that name appended to it already. So I could name this and that will name that. So now if I were to generate the report and go down to the custom area analysis, I must not from data. That is not updating. Apologies, that may be broken at the moment. It shouldn't be, but generally you should be able to name the areas and it should show up in the report. So given the modified areas, I could then go and export them as a shapefile. So I export that and you can see it downloaded here. This could be, then you can use that externally, or you can load it back in the application later if you want, and that will include any modifications made in the application. So next we'll go into importing land cover scenarios. So this will cover the different land cover scenarios that Koya had mentioned, which are the Pearl Harbor development scenarios. There are 6 of them. If you go to the workshop, there are links to download each of those if you want to download those and upload them into the application. So I'm going to, as an example, use scenario 1 and 3, which are the corridor development with high level protection and also corridor development with no protection. If you want to bring them up side by side for easier comparison, you can bring up a second map. So I'm going to, on the first map, import. So this time we're going to use the import land cover raster. So if I select scenario 1 here, it will import that scenario. You can see that changed. Caprock. And then on the second map, I'll import scenario 3. So you'll have this warning with scenario 3. So that's just telling you that that specific file had modifications to background cells, which are the ocean cells, and those can't actually be handled by the application. There are no recharge points for that. So it'll just give you a warning that no analysis will be performed on those cells. It's not a problem. So if you go into the recharge rate for that, and then you can see differences. Obviously, the scenario with protection will have a lower impact on groundwater recharge than the scenario with no protection of surrounding areas. You can also, so I could go to the percent change mapping and you can see the specific areas that are different, which then this is the scenario with no protection. So there's no change over, I'm sorry, this is the scenario with a high level of protection. So there is no change to the native forest areas over here, which is the reason for the slightly higher recharge rate, as opposed to this area, which has other areas that have a lower recharge rate. So that's the reason for the difference. And so you can also, instead of basically bring them up side by side and comparing them to the baseline, it's also possible to compare the scenarios directly to each other on a single map. So if we close that and go back to a single map, what I can do is import. So I'm going to go back to import land cover raster, and go to the advanced options and select override default land cover scenario. That will overwrite the application default land cover usage with this scenario that I am importing. So it will cause any further modifications to be compared to that scenario that I upload instead of the application default. So if I select scenario 1 again, import that. And if you, it's taking a second to load. Sorry about that. It looks like my Chrome's acting up. I don't believe that that's actually an issue with the application. I think that's just the computer. I apologize. Let me just reload that. Okay, let's try that again. So if I import override default line cover scenario and then load scenario 1. And then, so you can see that I imported scenario 1 raster, but it is showing a 0 change. That's because we overwrote the application default scenario with that. So everything is being compared to that loaded scenario now. And then if I were to import that, not select the overwrite option, go to scenario 3, that will create, that will update the land cover based on the scenario 3 land cover changes. And if you go to recharge rate, that will now directly compare the 2 different scenarios. So this scenario 3 is now being compared to the scenario 1 recharge rate. So if you wanted to see that, you can see the exact changes. And of course, scenario 3 has a lower recharge rate. So scenario 3's recharge rate is going to be 1.45% less than scenario 1. And then, so we can go to the next portion, which is importing and exporting the state of the map. So if I made modifications to the map state and so modifications to the land cover and created some custom areas, I can export the entire map state using the export button. So basically just export the land cover and custom areas. It's also possible to export the recharge raster, so that's not used on import. That would just be for external usage. So I can create a download package with all 3. You can specify between 2 different file types, which I'll go over a little bit more later, but we'll just use the ASCII grid format for land cover and recharge. So hit export. That will create a download package. And now if I were to close this map, create a new map, I can import, if I select both of these and go to select files and downloads, I can then import the download package that I just created, and it will restore the map to what I had before. So that will import the shapefile that representing the custom areas defined on the map, as well as the land cover that was being used by that map. So you can use that to kind of save your work and then go back to it at a later date, or you can also obviously use that to just have the data from the application that you can use for external analysis. So now I'll just go over some of the details of the different file formats that are used by the application. So specific for custom areas, it uses shapefiles. There's really only one standard that it uses for that. But for the raster data, so the gridded land cover and groundwater recharge data, there are two different options. There's coverage JSON or CovJSON, which is a JSON standard for representing grid geospatial data. There is a link in the workshop and to that standard, the website for that standard that has some information about that and how that's formatted. And then there's also the Asc files, which are just ASCII grids. And I can kind of show you, so the files, the Pearl Harbor scenario files are represented using this format, and I can kind of show you how this appears. So if we go to one of those files, you can see that it's a simple 6-row header with some information about the grid's position and size of the cells, and also the node add values, followed by all of the data in a just ASCII format grid. So it's a space delineated with new lines between rows. And then, so each of the grid files also comes with a projection file. So that would be this. And this file contains some information about the projection used. So in zoning data, the grids used by the application use Universal Transverse Mercator, or UTM map projection. So you can see it's not lat long. These are UTM coordinates. So the projection file has information how to locate the specific projection used by the application for grading. So if you want to grade your own, use that. And then, so that covers the main features of the primary workspace and tool. Koya went over some of the other components of the application a bit. The background has information about how the groundwater recharge data is generated, the models used, and some about how it is stored and retrieved, as well as information on the limitations of the application and references for the tool. There is also an about page that has just information about the authors and publications, and then instructions, which is pretty useful, which has a breakdown of how each component of the tool works, what it does, as well as if you hover over specific areas, it has visual aids displaying, where the items are. You can also hide this if it's in the way, but it's useful. So if you want to import or export something, you don't know where the control is, hover over this area, it will show you where it is in the application. So you can use this if you're using it by yourself and you get lost. This is a good resource for demonstrating where specific parts of the application are. And I think that about covers everything. If you have any questions, I'll answer them. So I believe that's something that we want to discuss today. Currently, I don't think we have funding for that, or that's not part of the current pilot project. So right now it's just for the island of Oahu, although we would like to extend it to other islands.
Yeah, that's correct. Yeah, that's part of today. Part of the engagement with the community and stakeholder folks who you all represent today to discuss some of these things. So I guess with that, yeah, Jared, you want to stop sharing, and we'll just move into, I guess, some of the discussion and question portions of things. So I think, yeah, we just did that. So yeah, so let me make sure I get the chat up here so we can see if there's anything else. Oh, here's a question. How easy would it be to update the base layer for other land cover types related to the question for Kolia?
Sorry, update the base layer for other land cover types. So that would be the portion where when you update, sorry, when you import a custom land cover, in the advanced options, there is a toggle for updating the baseline land cover. So if you had a land cover that you want to replace the application default with, when you import it, all you'd have to do is go to the advanced options, select that toggle, and it will update the baseline land cover with that scenario that you upload. So I think this land cover that's being used by the application is from 2010, I want to say. So if you had a more up-to-date one, you could also replace it with that.
And Kolia is going to have to weigh in here too, I think. But I think the land covers that are currently in the application are used in the were used in the model, and so they have the recharge calculations for each grid cell under the two different scenarios.
Yeah, I can fill in here. So basically, what this tool represents is the same land cover that John Engott had used in his report in was that 2017 that came out. So basically, we just converted that report into a rasterized version and replicated it with a different model that ran the rasters and got really similar results. And that's, so we only have the land uses that, or the land cover classifications that were used in that report. Of course, if you have more information of where different land covers would be at a certain time, those could be implemented, those could be added. There's no limit on these 29 land covers. If you have information about it, it could be incorporated. But we just followed what Engott had and basically replicated what he did.
Okay. Yeah, so welcome any questions at any time. We're just trying to, in our discussion portion of here, guide some of the discussion into some of the areas that we have seen or identified that there might want it to be some discussion on. So one of the other ones is, now that whether you've used it before or this is your first time seeing it and you've seen some of the application here, are there use cases related to some of the work, your research, or your management that you're interested in using the tool for, that you might have questions about on whether or not it would be appropriate, or ways that you might be better enabled to do it? And folks are welcome to unmute themselves and ask questions over the mic.
This is Steve Turnbull with the Army Corps of Engineers. I did have a question.
Okay.
Were you able to field verify it anywhere with any lysimeters or any shallow wells or any field test plot to sort of check the calculations and what it comes up with with measured field data?
No, this is more a specific question to the recharge itself, and I believe there were some cases where they tried to compare it, but on an island-wide scale, no, that's not possible. So I think there were some areas where it was, but I think that you would have to ask either John or somebody who did that at that point and see if there's any direct comparison. I'm pretty sure they looked into anything that was available, but I can't tell you right now how good they were. But typically those are really small scale and not really, are just only for a few points and not really helping you to basically see how good the whole recharge model works on an island-wide basis.
Okay. So I'm not seeing a lot of questions about this. Maybe we could break out. So Ryan has a question here in the chat. Ryan, do you have your mic? You can just ask this.
It's not really a question. It's just an idea to create more work for people. I just had, yeah, I had this idea. I talked with folks about a model like this, just in terms of land cover change, what land cover change means across the board. And I just think another application for this tool, if you are able to manipulate the land cover like that, is to, you know, if you were able to come up with a carbon value for what those changes would be, that would be, you know, an add-on. Obviously, I'm not trying to take away from what this tool does. It's awesome and great work, guys. But just maybe a thought down the road. And I know carbon sequestration and those equations are way more complicated. I'm super oversimplifying it here, but just wondering if maybe you had thought about that, or something that, you know, you think you could explore. I know you guys are the Pacific Water Center, so.
Well, that's a really good idea. I don't think anybody has thought about that yet. So I think that's definitely one thing we can write on the list of things that we could look into. If there's interest, if that would be, yeah, to add that to it. I don't know how complicated it is, but certainly that seems to be something that's really useful. So if there's interest and somebody wants to see that, then yeah, I'm pretty sure we can look into that, how to incorporate that.
Thanks. Yeah, you could probably start off pretty simple and then be developed further with like another proposal or something. But again, I'm just super simplifying all of this. Thanks, though.
Yeah, thanks, Ryan. Cheyenne asks, when would you expect other islands to be available on the website?
Yes, I will do the next slide, right?
Yeah, I think it's at this.
Oh, no, okay.
I think there's other scenarios.
Yes.
Or wait, no, we did. Sorry, I went too far. Yeah. So right now we don't have an estimate of when other islands. Kolya, you showed that slide that had some of the other. I think it's a different model. Were you saying?
It's a different model. It's on the polygon level, and it's, of course, every land cover is tied to one climate scenario, and then you run the model and get an outcome. So it's totally different than what we're doing here, but it could be the basis for expansion. So if people think like, well, the land cover that, or all the other islands would be very valuable to or certain islands would be valuable, then if there's funding, that could certainly be done. So I think there is, we have, and if the legwork has already been done by basically putting together the land cover, the current land cover, and the climate scenarios, and setting up the model files, it'll be not that difficult to change that into the approach that we did and convert that into the tool. But then again, do we do all islands? Are only certain islands of interest? And then back to the next slide, which climate scenarios are the most valuable? Should we go with all of them? And I mean, of course, everything, the more you request, the more work it is. So I guess it all comes down to where is the interest? What do people need and what do people think is valuable to them? And then who has money for that too? That's another question.
Suggestion from Melissa here is there might be interest from watershed partners across the state.
Yeah, I totally can see that.
And Tom asks, is anyone from this team working on forecasting water resource versus usage for the foreseeable future?
Yes, we all do that. For our groundwater availability reports are all doing exactly that. But that's a different question because that goes beyond the recharge. That includes groundwater pumping and a groundwater model. I mean, that'd be nice to couple that one with a groundwater model. That would be the next step too.
You're saying couple the usage?
Well, I mean, because groundwater recharge is an input to any groundwater model. So if you can vary your groundwater recharge and couple that with a groundwater model and get immediate result for what the groundwater model looked like, that would be very interesting too. But I think might be, I don't know, might be too computational intensive, but just throwing out an idea.
So I think Tom asked, where might they access I guess that research that you're talking about?
Okay, just go on the, I guess the main one would be the Izuka, I guess the professional paper that's coming out soon. That would be the best one. And Molokai report just came out. The Molokai groundwater model. We have a Maui groundwater model coming out pretty soon. And I think WOW is also in the works. So that might take a little bit. But in general, the Izuka that I mentioned before with the Caprock, the Izuka and others 2018 report, that one is probably one that gives you a good start. Although it's more generalized based on existing data.
I see that Emma raised her hand. Emma, would you like to?
Oh, yeah, thank you. I did want to respond to Ryan Longman's question about carbon sequestration, because we actually have gotten the carbon sequestration potential index data from the US Forest Service and USGS. So that's available, and I don't know if that can be thrown up on this web map that you guys have here, but it is out there, and we have our own web maps that have that can be viewed. But the question that I actually wanted to ask was about how this will be interfacing with the work that Lucas Fortini is doing with the runoff rates, because what he has described to me is that he's working on a project that sounds very similar, except with, instead of recharge and looking at different scenarios, you'd have all the same scenarios, but look at the difference in runoff.
Yeah, I'm pretty sure those. I'm not quite sure what he's doing, so maybe I have to connect with him and see what he does and see if that fits into it. Runoff is always a big question because there's a big question mark on runoff, because we only have certain gauges where we measure the runoff, and we have to estimate it for all the other ones based on some complicated analysis, and it's not. I think there's a big question mark in runoff for the ungauged basins.
Yeah, well, I guess you should check in with him, because it'd be great if this could all be merged together, and hopefully you folks aren't doing these things kind of on parallel tracks, because
Is he doing it for island wide or a specific island or all islands or?
I believe it's statewide, and I don't mean to represent his work for him, but this is what he's described to me. So best to get it straight from him.
Yeah, sure. Good idea. So I guess your question is coming out really like, when are those islands going to be done? I mean, it really depends on people coming forward and saying, well, we have an interest in these specific islands, and of course funding it. That's another thing too.
Okay, there's a question and comment from Aurora. I think she says, with regard to landscape planning, Hawaii Island has tax incentives for landowners to conserve native forests. This kind of tool also helps see if conservation restoration in those TMKs also presents net benefit for recharge.
Okay.
All right. Oh. Might be good to have the county planning departments. Coley, did you and Scott, did you present to any of the county planning?
No.
No, okay. We'll put that down there. All right, thanks. Jeremy, do you need to determine that there's enough interest for it? So I guess we haven't decided, I guess, necessarily a threshold, but we're starting to, ask, what would be, where's the most interest, I guess, from folks. And so that's coming from these groups of, this group of stakeholders that we have here, and also potentially, some of the county and other state agencies that would be interested in some of this. Coley, you have anything to add to that?
Well, I don't know. I mean, it's really, in the end, it's all about who gives money to push this forward, right? I mean, it's not like who screams the loudest. In the end, it needs to be funded somehow. And I'm pretty sure there could be combinations worked out for certain groups or certain things.
Okay. And then Tom points out mayors might be one of the funding stakeholders.
Again, how much funding is needed, that also depends on what needs to be done. So I guess, statewide and all the climate scenarios that I showed from the Water Commission, of course, it's going to be more than just adding one island and no more climate scenarios, right? So it depends on, funding depends on the workload in the end. And I can't give you a number right now, but it's going to be, of course, the more islands and the more climate scenarios, the more work will be done or necessary to do that.
So it requests how much funding is needed to get the other islands for, I guess, under the current scenarios. I guess I don't have an estimate for that.
We can sit down and talk and see, and maybe maybe this should be more like a start for discussion of how to do this.
Okay, that'd be something interesting. Oh, I think I missed something above. Let's see.
Regarding to Ryan, yes, we're only using statistical downscaling mid-century. So the other ones are possible. They're out there. So yeah, it's
Yeah, there's two dynamical downscaling projections for end century. We're aware of one of them that came out of UH, but then there's another one that NCAR produced and published about 2 years ago. So just, I mean, I don't know if you have an idea of being able to select between the different scenarios because they are different. I know with the mid-century, we're stuck with that only one option, but if there's 3 options for the future and you're making land management decisions, it might be good to be able to look at the range of possible scenarios beyond the RCPs, but even the different products.
Okay.
Yeah.
Just wants to tell Aurora, thank you for the suggestions here on the Maui and Hawaii Community Foundation. And Eva is going to share with the Maui County Planning Department. Thank you. Okay. I guess if we moving on to one of the next areas would be, sounds like there's interest in the other, all the other islands potentially. Is there interest in other climate scenarios that Kolya kind of mentioned, I guess? Because which ones we currently, is the mid-century 2041 to 70, is that what we have?
yes.
And
You have mid-century, and that one is kind of a dry scenario because that's the statistical downscaling. If you go into the dynamical downscaling, you get more into the wet scenarios. Aurora asks if there's a way to pull in El Nino scenarios. Well, I mean, if you have data on how El Nino affects the future rainfall scenarios, yeah, that'd be good. I mean, any kind of scenario can be ran. You just need an estimate of what the rainfall will be in the future, and it could be incorporated. If that is, yeah, you know, it's not. Basically, the tool can take any data that you feed it into it. So it's all like, do you trust it and do you think that's useful? That's another question, but yeah, it can be done.
Ryan thinks that it would be easy to create these scenarios. So, okay,
I
Ryan.
guess I just bring it up because Heidi's presentation of the Lanai drought scenarios at the recent Water Commission meeting kind of highlights, you know, how these extreme events can change patterns or, you know, create stressors on the resource that people actually perceive. People have a hard time projecting 50 to 100 years out from their lived experiences. So I guess I was thinking like using a historical scenario to kind of illustrate how those patterns changed in that extreme year, just for learning, you know, even if we can't project El Nino.
Yeah, might be worth looking into it. Same with historical. I mean, if there's data out, I mean, we have a lot of historical rainfall, so you could, yeah, it could be done. It'd be more like into historical land cover that would have to be also implemented if you really want to go back in time. Although generally it seems like for planning purposes, it seems more of interest in going into the future than going back into the past. But for groundwater models, that could be a good application.
Okay, we'll jump into this other one here. This might be some more interest in some additional features. So other inputs or output data types, finer raster resolution. And then I think this one probably has already been brought up, other water balance components. Does this work have implications on developing resources that don't rely on an aquifer rendered unusable by a leak from Red Hill?
Well, it has implications in general to figure out where recharge, how recharge could be changed in terms of if land cover is changed, how that would change the recharge. But I don't think it has a direct implication on whether Red Hill is there or not, because that's a whole different question of a groundwater model and like water quality model too. But so this future discussion is the ASCII file and the CUF JSON enough to handle all the data? Is that enough, or are there any other data types that might be necessary that we need to add on? That's one question we have.
Yeah, finer raster resolution, since currently it's 75 by 75. I think you brought this up at the end of your talk.
Fairly coarse, yeah. Of course, everything smaller would be nicer, but I don't know. Of course, there are limits.
Yeah, there's the trade-off of and you can go down like 1 meter. Is that, you know, at what point is that useful? But also then you see performance degradation, and the amount of data transfer back and forth gets a lot larger.
And so far, we only talked about recharge. Is there any interest in the other water balance components, rainfall, fog, irrigation, runoff, evapotranspiration? Because those are byproducts of the water balance model and could easily be appended into the database and being made available as output. But we thought we'd keep it simple in the beginning. And if there's a lot of interest in these components, then they could be added.
All right.
Not so much. Okay.
Okay. Oh, hard to see a future that would not have more interest in what you're all doing. Oh, thanks. Well, one of the other things is there's interest in other islands. There's been brought up that potentially the software infrastructure might be able to be generalized for other regions.
Samoa, Guam.
Potentially development could go in a way that to make it simpler to upload, I guess, the underlying recharge data and scenarios for different locations. So.
Hey, Koya, how's it? This is Jeremy.
Hey, Jeremy.
From the Water Commission.
How's it?
Good. So I just want to chime in real quick on this one, and perhaps maybe the last slide, but since I didn't hear anyone else say anything, but I think the approach that you guys took, you know, if the documentation of the, I guess, the process is clear enough and can be replicated, I see great potential in using it for other places. And I'm talking more from like a water resource planning standpoint, right? You know, so I think Aurora kind of mentioned in some of her statements, but you know, we're looking at it more from using it for people looking at how different land use changes are impacting recharge and the water budget, and you know, as sort of a guide that everyone can use, right? So that when we make policy decisions, like other people can sort of check the work and come to their own conclusions as well on you know, what impacts land use changes or are going to affect sort of the water resources of the area, and kind of help us as policymakers start to recommend maybe different strategies or approaches to balance management and protection of the resource. So anyway, yeah, I think if the generalized approach that you guys took is enough that it can be applied in other places, and especially in Western Pacific or other parts of island states, what inputs are needed and sort of the computational requirements on the data side, to host things like this. And for web tool, yeah, I just want to say, like, I think it would be probably really useful, even though I'd work just in Hawaii. That's my area here, working for the state government, but I think it'd be really useful in other places.
Well, it all comes back to, is there data available? Is there basically a water balance model that is running? So I mean, we're only basically taking the water balance model and rasterizing it, in a simple way, rasterizing it and making it available for every land cover for every cell. So if you have a water budget model for Samoa, for example, I mean, that could also be rasterized and run with uniform land covers and then put into this tool and made available. It all depends on, is there enough data available? Is the water balance model, is it solid? Does it have enough I don't know, does it consider all the components, runoff and all these things, or how good is it? But if it's available, then it's totally possible to include it into the tool.
Yeah, I think no, yeah, exactly. Like, but what you guys are showing here is like a good end state to show people, like, if we have the data sets, we work on the data sets now, like for some of these places, this is the end state you can get to, where I think a lot of policymakers are looking for. Basically what you're creating is sort of like a decision support tool, right? I mean, you're changing land cover, different scenarios. I mean, some things are out of our control, like how the climate's going to change. Well, maybe that's not our control, but it is in some sense. But like, yeah, so I mean, you're creating this tool that visualizes how different decisions will change. And yeah, and so for people in Guam, for example, who might not have the data set available, it's like showing them that this is where you can get, as long as you start working on those initial data sets now. And I think that's powerful, like to maybe even larger stakeholders who are like some of the federal agencies that are working in the Pacific, but maybe have money, to fund where the local entities can't maybe make up that. I think that's where, anyway, this helps plant the seed, I guess, is what I'm thinking.
Yeah, there's no reason not to use it on other islands or other areas where you have a water budget model going and use and apply it there. And I mean, the beauty is really, it could be all up to the user to decide what he wants to change. So it's not, he doesn't have to say, okay, this is my land cover and I want the product in 3 years. So it's really like, okay, I want the land cover not change now, and I see exactly the result immediately. So that's the beauty about it.
Okay. We've kind of discussed, I think, some of this here and gotten a lot of good suggestions on, how would we move forward with adding other islands potentially, or some potential other partners to explore that would want to extend that, I think, some of the work or do some of this. So if anybody else has any suggestions or comments, we'd be happy to hear those at this point as well. Okay. And then, at this point, just, anything else that anyone else has questions about or comments related to this or the project at all. All right, thanks for saying that, Aurora. Yeah, software is definitely an iterative process and a tool. I agree. Okay. Well, if there's not much else here, I guess I'd just like to wrap up and thank all of you who attended and stayed for the entire workshop. Thank you for all of your input. And looking at the tool, we'd just like to acknowledge some of the funding sources here. The NSF grants, the EPSCoR EPY grant that funded this, as well as the underlying cyber infrastructure grants that help fund the infrastructure for being able to actually host and build this tool. So TAPIS, the TAPIS framework and the Agave platform are two of the things. And then thanks to all of the different partnerships with all the university, federal, state, county, and community stakeholders that have been part of the EPSCoR and EPY project. We really appreciate all of the help and all of the feedback and the partnership that we've gotten on this project. And finally, just a plug here. So somebody brought up in the chat about some of the rainfall data sets. So what's coming is going to be the Hawaii Climate Data Portal launch that will host a lot of these precipitation data sets and temperature data sets. And we've also discussed integrating the recharge tool, at least accessibility wise, being accessible through the portal with this. So this is another project that Jared and I are working on with Tom Jambaluka and Ryan Longman and Matt Lucas and a number of other folks. So if you're interested, you can attend the launch meeting and hear some more about it. I'll paste the link in the chat here. If anyone has not seen this before, you can go there and register. Kalia, you have anything else to say?
No, except thanks everyone for staying on and showing interest in the tool. And I think we got some really nice ideas too, what could be expansion beyond what we thought already. And maybe there will be some discussion about future expansion. So I think everybody who's interested should come forward, and we'll just have a meeting and we'll just figure things out.
Okay. All right. Okay. Oh, thanks for all the wonderful comments in the chat, everybody. And yeah, thank you again for the discussion. So I'll stay on, we'll stay on here for a few more minutes, but everybody, we'll just call the workshop close at this point. So you're welcome to take off. But if you have any other questions or you want to chat, we'll just hang out here for another few minutes.